In this video, we're going to introduce how to use Yenka for creating logic circuits. So using the NOT and OR gates that we've been using in electronics and control. What we're looking at just now is what happens when I open up the Yenka software package. Now, because you are at home and because Yenka is only free for use at home, then we're going to click I'm at home here. If you're accessing this via Citrix on the college network, you'll probably come straight to this screen and not need to click the I'm at home button. So either way, after that stage, you'll come to this part of the screen. In Yenka, there's actually a wide range of products, and in this course, we'll only use a fraction of them. And everything that we need to use for electronics control is found under the Technology tab. We'll be using some different parts of this for analog electronics later in the course, but for digital electronics, we're going to select the electronics product here and click OK. You'll see that it disappears and we're left with this screen here. Here we can open, save, print, and you need these sorts of things once you've got some circuits built already. But we've not got anything yet, so I'm going to click New over on the left-hand side here. And we've got a blank screen, a bit like our whiteboard, and we have some folders on the left-hand side, which allow us to select equipment to use. We're not going to be using the PICs or presentation. We're going to be using electronic components. That's where we're going to get our logic gates from. And we're going to be using lab equipment, and that's where we're going to get some of the switches and indicators we need to send our signals into our logic gates and show which signal is coming out. So let's start with a very simple example. So I'll go into electronic components first of all. I'll go into digital processing because that's the type of electronics we're looking at. And you see there's some options here. For the purpose of this course, you can pick either digital 4000 or digital 7400 series. These are different specifications of component, like they act physically different in the real world. And if you're interested, you can learn a lot more about these. But for our purposes, they're going to operate the same in Yenka. So we'll take the 4000 series. And our first option here is logic gates. And here you should recognize some of these symbols. Some will be new to you as well. But all of our familiar gates, the AND gate, the OR gate, and in this package here, the NOT gate is called their inverter. So if you're looking for a NOT gate, you're looking for the inverter. We're going to have an AND gate for this example. So I'd click on the AND gate and drag it onto my screen. And there we go, we've got a little AND gate in the middle here. These are by default set up with 2 inputs. If we needed more inputs at any point, if we go into a 3+ input folder, you can see there's different gates that allow us to put in more than 2 inputs. But for our purposes just now, we'll only need 2 inputs. So that's our logic gate on the board, if you like, at the screen. We now need to send signals, 1s and 0s, into this gate, and we need a way of indicating what its output is as well. Well, we'll find the components we need in the section called lab equipment. Go into lab equipment, go into logic, and everything we need is in here. So the things we're using are the logic inputs. We'll talk about latching and push button in a second, and a logic indicator. We'll be using this for all of our logic circuits. So I'll take this just now. The logic indicator is effectively like a little LED, and when there's a 1 as the output from a gate that it's connected to, it's going to go on, and when there's a 0 for the output, it's going to stay off like this. And just now it's not connected to anything. So I'll connect it to our AND gate at the moment. So as I hover over the left-hand side of it, this little black box appears, and if I click that, it gives me a wire, and I can join it to the end of the gate. The other box goes from being empty to solid black, and I click that and it's connected. And you'll see the indicators remain white because currently there's no input into the circuit. That's what we have to do with these logic inputs. We're going to use latching logic inputs just now, so we're going to have 2 of them because we've got 2 inputs. So I'm going to drag one and put it here, another and put it here. And these are switches which can be set to 1 or 0. Their default position 0, off, and we switch them on, we're sending a 1 into that particular branch of our AND gate. The difference between a latching and push button input is latching, once we click it, it will switch from 0 to 1. For the push button, we have to hold it down in order to keep it set to 1. So we don't want to do that at the moment, but you find as we go through the course, there might be some circuits we want to build where we have to hold down a button. We can look at that a wee bit later on. So I'll connect this one to the top input, and I'll connect this one to the bottom input. And you'll see here so far nothing's changed in our circuit. We have 2 switches connected to an AND gate, and the AND gate connected to an indicator on the right hand side. Now, as I said, both of these switches are by default set to 0, but look what happens if I click one of them. If I click the top one, you can see a little red dot appears next to it, and that red dot is carried over and appears next to the AND gate as well. And what that red dot's telling us is it's a live circuit, and so there's a 1 in that position. So there's a 1 coming out of that switch, and there's a 1 going into the top part of our AND gate there. But as we know with AND gates, you don't get 1 as an output unless both of your inputs are 1. So let's press the bottom switch now. And you can see that the red dot appears on the line just to the right of the switch, and again just before the wire goes into the AND gate. And of course, more obviously, is that on the right hand side, our logic indicator has gone from white to red to show that it's detecting a 1 signal coming out of our AND gate. And one of the first tasks we're going to get you to do with Yenka is to do the same for the NOT gate, which is called the inverter, and for the OR gate, to make sure you can build these circuits and check they work out the same way. And of course, have a go at building the AND gate to make sure you get the same result that I have. So before we move on, let's save our work. So I'll switch it off, not that I particularly need to. And down the bottom here, you can see some symbols. So I can delete objects, I can pause the model because it's currently running a simulation. We don't need that just now. There's also a button to save the model, so I'm going to click that just now. It's going to invite me to save it somewhere on my computer. Now, I've got a folder that I use in teaching and electronic control, and I've got a Yenka folder here. So I'm just going to call this AND gate and save it there. So I've saved my work. And when it comes to doing the assessment part for digital electronics, you're going to need to make sure you save your work. This is the file you're going to share with me once you've completed the assessment for simulation. So you want to make sure that you save your work so you can submit it. It's very easy to lose it if you don't. So just now, because I'm just working in a demo, I'm just going to delete everything I've got here. And I'm going to build an example circuit from the course notes. Now, this is the circuit that's on page 14 of the digital electronics notes. And I've picked one of the ones that's a real world example of the burglar alarm system. The reason I'm doing this is to demonstrate how to build a real system in Yenka, because that's what we're going to be doing in the assessment. You'll be building some kind of device, and you'll be wanting to label all of our inputs and outputs as well. So we're told in this circuit what should happen is a burglar alarm is to sound if a master switch is on and either a light beam is broken or a pressure pad is stood on. So let's set this circuit up. So we're going to need an AND gate because we need to have the switch on, and we also have one of these 2 conditions met. So we'll get our AND gate over here. And of course, you can, if you're building this, you can copy it off page 14. One of the conditions is the input that the switch is on. So I'll take on one of our latching switches and I'll connect it here. That's our master switch. And we can actually label our diagram, which we'll do in a moment. And then the other condition that needs to be met is one of 2 things. Either the light beam is broken or the pressure pad is pressed. So I'm going to have an OR gate here to divide those 2 up. And the OR gate will be the other input to AND gate. And so we've got a switch for the pressure pad. Now I could use the push button here, so it has to be held down. But I think for demonstration purposes, we'll go with another latching switch. So that's our push pad if that's pressed. and it's if the light beam is broken. So if the light beam is not one, so we need an inverter for this. So we'll have our NOT gate in here. We'll connect the NOT gate to the AND gate. And you can see already the NOT gate's got the red light on the right hand side of it, because if it's got nothing coming into it, it's automatically saying it's a 1 here. So the light beam is acting as if it is broken unless we tell otherwise. And so we'll have our logic input here as well, and connect that up. So I suppose what we should do first of all is switch the light beam off by saying it's not broken. So the light beam is not broken at the moment. And of course we need our logic indicator at the right hand side. So if you look at page 14 of the course notes while you're doing this, you'll see this is the same circuit. And we can test out all the various scenarios. And this is one of the things you do in the assessment. You'll be building a circuit, but you also be testing it to make sure it meets the criteria. So one of the things we wanted to happen is the alarm system doesn't go on unless the master switch is on. So you can see I can toggle the light beam broken or not. I can toggle the pressure pad. I can do a combination of both, but that right-hand indicator light is not going on. So currently that seems to be working. If I switch the master switch on and the pressure pad, then the red light goes and that's the alarm going off. The pressure pad is not pressed and the beam is not broken. Master switch is on, nothing's happening. But the light beam is broken, so we switch this on. It's going through the NOT gate. Switch off. It's going through the NOT gate, getting our 1 signal. And again, on the right-hand side, our alarm system is going off. The buzzer's ringing. So the bell's ringing. And so that's good. But what we can do with Yenka is actually make something a bit more meaningful. If we go into the presentation tab at the end here, we can add some text to our diagram as well. So these things all have names. So we have a master switch. And of course, you've got all the various different things to change your text. But I think this is straightforward enough. We've got our master switch here. Dragging in another text box, and we have a light sensor. And we've got the pressure pad. And of course, on the right-hand side, we have our alarm bell. So when you're building up your own circuit, for whatever the challenge is in the assessment, you want to label all your inputs and outputs so that we can have a system that is actually meaningful. So now that I've put labels on it, what I'm saying is, if this master switch is on and this light sensor has been broken because it's the opposite of what's happening here, that's the alarm bell going off. And so that's how I would create my system. And of course, I'd want to save my work as well. Now, I think probably should have created a new model for this one because I'll be saving it over my AND gate. So make sure you don't do what I've just done. Always come out of it after you've saved it. I'll click save just now and see if it works. I've just saved over the AND gate. Never mind, there's a lesson for you there. So that's how we use Yenka as a quick introduction. In class, you'll be given some tasks. We're looking at you to build up the AND or the NOT gate and check that you get the expected outputs. And we'll also go through and build up the circuits that we used in task 2 and task 6. And again, checking that we have the expected outputs.